Hey guys, so we are doing a project where we are creating a physics engine that will allow us to use some of the equations that you learn in Physics 1A in SFML and C++. So the first thing I want to do is just give a quick overview of what we're talking about with these physics equations, just for anybody who isn't familiar with this stuff. So, as Quinton will introduce, our first class will be the kinematics class, which talks about the kinematic equations, right? So those are the equations of motion that we deal with in physics. So if I have this ball here, it's got an initial position in my hand, and when I throw it to my other hand, I do it with a velocity, and it has a final position. So that can be modeled, the arch that it follows is projectile motion, that can be modeled with the equations of kinematics. So that will be our base class. Uh, from there, we're going to develop more classes. So
So for our final project, we're going to be creating a physics library, and what we're calling the first layer of our project is the kinematics class. And in our kinematics class, we're going to use object-oriented programming and separation compilation to describe things like mass, velocity, acceleration, and direction. All of these things will be their own classes, but our kinematics class has a relationship with all of these things in order to describe the kind of movement that we want for our SFML objects. So for the functionality of our physics library, we'd like this to work much like you would expect a physics tool to use. That's what we want this to be. Not just an SFML toy, but a tool. We'd like to be able to have the user input a position function, something like you would see in a basic physics 1A type problem, in order to display things like position, an acceleration function, a velocity function, like a realistic kind of motion that you would expect to see in physics. So for some potential challenges that we're foreseeing so far in this project is defining what time and distance are on a computer screen and how that scales versus something like a real world meter and something that you would want to deal with on the screen. We need to determine a clock method that presents the user with a satisfying view of objects moving around. So not just the kind of bouncing that we had done previously where you can just set it to infinity and it goes completely flying off the screen. We want our objects to move in a real world scale in meters per second to be more useful and something that you can take advantage of. So we're going to need to determine how to represent a constant unit of distance using pixels. This unit will need to be static and predetermined to work with all of the following functions. So in 3 weeks' time, we're hoping to have the majority of our kinematics class done. This is somewhat of a tall order, but this is a critical milestone because the kinematics class is the base class from which everything else that we plan on doing is going to be derived. Yeah.
as Quinton said, we are going to be developing the kinematics base class. From there, the next class we're going to introduce is going to be the force class. So the force class will be a derived class from the kinematics class, and it will add in the object of mass. So this ball has a mass, and when I drop it on the ground, it hits with a force, mass times acceleration. So using that, we can get some interesting information about what's going on when the user gives the object that they're moving a force. Our final class in the physics library will be the momentum class. Again, we're going to add a mass object in the momentum class, which will be a derived class from the kinematics class. And what happens this time is now I've got a ball and it's got a momentum when I throw it. And it's an elastic collision, which means that it deforms and bounces back. So using some of the equations from physics, we can take the mass of the ball times the velocity of the ball, and we can model what it's like when it hits the ground and bounces back up. Additionally, the user can now add multiple objects and have those objects collide with one another, and we can potentially accurately model this situation. The final part of our project, which will be separate from the physics library, will be the driver program. The driver program is going to be a program that demonstrates each of these classes, and it's going to be a program all its own that includes the hashtag include brackets physics at the top.